Good morning, students. I welcome back you all to this class of mathematics, and we are going to do exercise 7.2 of chapter integrals. And in this exercise, we are going to study the method of substitution. Now let us use the method of substitution for finding the integral of some basic trigonometric functions. As you know that we have done the integration of sin x and cos x, and that we have done by using the method of antiderivative. But now consider tan x. You know tan x is not the derivative of any expression, directly any expression. So how to find the integration of tan x? For that we write this tan x as sin x upon cos x. And now we shall make a substitution. What? We shall put cos x to be some variable t. After that, differentiating both sides with respect to x. So derivative of cos x with respect to x is sin x, and derivative of t with respect to x is dt by dx. And hence we can write that minus sin x dx is equal to dt. So let us try to make this substitution in this integral I that we are going to solve. So I, which was sin x dx upon cos x, it now becomes, now we have seen that sin x dx, its value is minus dt, and cos x we have assumed to be t. So now we can solve this further. I can take this negative sign outside the integral, and I have 1 upon t dt. Now I have to integrate this 1 upon t. Now students, you very well know that 1 upon t is the derivative of log t, and therefore its integral is log mod t plus a constant of integration. Now we have integrated in a variable t. So now after that we substitute back t, and we know that the value of t was cos x. So the answer is log mod cos x plus the constant of integration. So this is how we can integrate tan x. So now in a similar manner, if you have to integrate cot x, so you can write this cot x as cos x upon sin x. Now again we assume that this integral is I. Now I can assume we can substitute this sin x, the denominator of sin x. Let us substitute it to be t. Now after this, differentiating both sides with respect to x. So we get cos x cos x dx is equal to dt. Now you see, because the derivative of t with respect to x is dt by dx. So that dx got cross multiplied with cos x. Now making this substitution in this integral, so your integral I, it becomes, let us first write what was I initially. Initially your integral I is this. Now after making this substitution and this one, it becomes, now cos x dx becomes dt and sin x becomes t. Now we know 1 by t is the derivative of log t, and therefore its integral is log mod t plus a constant of integration. Why we have put the log mod over here? Because we know that log function is defined only for positive numbers, and therefore the number that we write here should be positive. Therefore we have put a mod. In case if it is negative, we have written a mod. Now we substitute back the value of t. Now we can see that t was sin x, and therefore it becomes log mod sin x plus a constant of integration. Now let us integrate secant x. Now students, in integration you have to memorize a few things. So we multiply and divide secant x by secant x plus tan x. So you can see this thing, this secant x plus tan x written in orange color. If you cancel it, it comes out to be 1. So you have made no change in the expression. Now you can see the secant x plus 10x written in the denominator. So I will put this secant x plus 10x written in the denominator as t. Now differentiating both sides with respect to x. So derivative of secant x will be secant x tan x. Derivative of tan x will be sec square x, and derivative of t will be dt by dx. Now what we can do is, from the expression written on the left hand side, I can take secant x common. So I am left with 10x plus secant x, and then I cross multiply this dx over here. So I get dx over here and it is equal to dt. Now you can see this expression and you can see this expression. You can see both the expressions written in box. Now let us move to our integral I. Now you can see here in this integral I, this numerator secant x plus 10x dx, it is here in this box. It is same as this expression. Therefore, this expression of the numerator here can be replaced by dt. So your integral I becomes dt upon, and this expression secant x plus 10x, we assumed it to be t. So it can be written as t. So now you have again 1 by t and derivative. 1 by t is the derivative of log t, and therefore integration of 1 by t will be log mod t plus a constant of integration. And once you have found the integration using the method of substitution, then you have to substitute back the variable introduced by you. You can see that this t is the variable introduced by you. It was nowhere given in the question. And therefore, you have to substitute back t by its value, which is secant x plus 10x. And hence we get this is log mod secant x plus 10x plus a constant of integration. Now let us find the integral of cosec x. Now as you can see here, I have multiplied and divided cosec x by cosec x minus cot x. It's also a trick. So there are some basic tricks in integration that you have to sometimes memorize, but later on you will become used to. Now I will make a substitution. Why I will make this substitution now, after doing so many questions, I can explain you. I am substituting cosec x minus cot x to be t. So students, listen, I have to substitute that expression to be t whose derivative is present in the numerator. This expression that I have assumed to be t, this can be either in the numerator or in the denominator, but its derivative should be there, then only I can assume any expression to be t. Now differentiating both sides with respect to x. So what do we get? Now you know derivative of cosec x is minus cosec x cot x. Also you know derivative of cot x is minus cosec square x. So it becomes plus cosec square x. And on the right hand side you have t. So derivative of t with respect to x will be dt by dx. Now in the next step, what will I do is that from this numerator I will take cosec x common. Also I will write this term first. So I will have cosec x minus cot x. So if I take cosec x common, so from this term, positive term, I am left with cosec x, and from this negative term I am left with cot x. Also I can cross multiply this dx over here. So I can write this dx over here and dt. Now you can see that this expression that I have written, it is same as the numerator of the integral I. And this expression, it is same as the denominator of the integral I. So let us make this substitution in the integral I. Here I can tell you that we have assumed this integral that we had to find to be equal to I. So now the integral I becomes, numerator becomes dt and denominator is t. So again its integration will be log mod t plus a constant of integration. So now I can again substitute back t, and t was cosec x minus cot x. So we have log mod cosec x minus cot x plus c. So now we can see that integral of cosec x is this. Now students, let us move back to the first integral that we had done of integral of tan x. There in the end, by mistake, we left this negative sign. So there is a negative sign here outside. So let us make this correction now. Now you can see that minus log cos x. Now I can use the property of logarithm and I can write it as log mod cos x raised to the power minus 1, which becomes now log of 1 upon cos x plus c, which becomes log of mod sec x plus c. Now with this knowledge of the method of substitution, let us start exercise 7.2. Let us take the very first and very simple question. 2x upon 1 plus x square dx. Now students, you can see here that for using the method of substitution, first we have to see that which term is derivative of which other term. I can very well see that 1 plus x square, its derivative is 2x. So therefore, I will put 1 plus x square to be t, because I know that its derivative is already present in the numerator. And then differentiating both sides with respect to x. So derivative of 1 is 0, derivative of x square is 2x, derivative of t with respect to x is dt by dx, and therefore we can cross multiply and we get 2x dx is equal to dt. So this we are going to use. 1 plus x square, already we have put it to be equal to t. And now let us assume that this integral that we have to find, that this is equal to I. So now this I becomes, you can see here in second box, 2x dx is dt. So I can write dt here because numerator is 2x dx and the denominator is 1 plus x square, which is t. So again I know that 1 by t is the derivative of log t, and therefore integration of 1 by t will be log mod t plus a constant of integration. And now after this you have to substitute back t, and the value of t was 1 plus x square. So we get log mod 1 plus x square plus a constant of integration. This is the answer. Now let us come to question number 3. So I am leaving a few very simple questions for you to practice. So in question number 3, you can see apparently we don't find any term to be the derivative of any other term. So in that case, when you don't see any one term is the derivative of some other term directly, so you try to simplify the expression further. So let us do that. And from the denominator, I take x common. So this denominator becomes 1 plus log x dx. Now students, you can see that if I will substitute 1 plus log x to be t, this 1 plus log x to be t, and differentiating both sides with respect to x, derivative of 1 is 0, derivative of log x is 1 by x, and derivative of t with respect to x is dt by dx. Now cross multiplying we get dx upon x is equal to dt. So now we are going to make these two substitutions in your integral I. So now you can see this dx upon x. This can be replaced by dt, and 1 plus log x, it can be replaced by t. Now again its integral is log mod t plus a constant of integration. Now this is all fair work. This is not the rough work. Now after that, in the end, you will substitute back t with 1 plus log x. So you get log mod 1 plus log x plus a constant of integration, and this is your answer. Question number 8. I have left the in-between questions for your practice. So if you people want, I can do a few more questions. Oh, you wanted me to do 4th and 5th also? Okay. I'll do it after this 8th one. Okay, now you can see that if I substitute 1 plus 2x square to be t, so differentiating both sides with respect to x, 0 plus 4x is equal to dt by dx, cross multiplying. So I can do this thing also, that I find the value of x dx, that comes out to be dt by 4. So I will make this substitution and this one in the given integral I. So this given integral I becomes, now you have seen here x into dx becomes dt by 4. X into dx, this is dt by 4, and root of 1 plus 2x square you have already substituted as t. Now we write it back in some different simplified manner. Root t can be written as t raised to the power 1 by 2 dt. And you know students that constants in the integrations can be taken common outside the integral sign. So I can take this 1 by 4 outside the integral sign. So now I have to integrate. This is the formula that we are going to use to integrate t raised to the power 1 by 2. So this is the formula, x raised to the power n. Its integration is x raised to the power n plus 1 upon n plus 1. So therefore, here 1 by 4 is common, and integral of t raised to the power 1 by 2 will be t raised to the power 1 by 2 plus 1 upon 1 by 2 plus 1 plus a constant of integration. This is all fair work. The substitution work that you have done, it's all fair work. It is not rough work. So simplifying further, 1 by 4 t raised to the power 3 by 2 divided by 3 by 2. So we get this. Now after this we can cancel this 2 by this 4, and we can multiply this 2 and this 3. So we get 1 upon 6 t raised to the power 3 by 2 plus a constant of integration. Now we have to substitute back t by 1 plus 2x square. So we get 1 by 6 1 plus 2x square raised to the power 3 by 2 plus a constant of integration. So this is your answer. Some of my students, they wanted to do a few questions that I have left for your practice. So let us do them. Fourth question is sin x into sine of cos x. Now you can see this is the composite function. So I have to simplify this composite function. If I put this cos x to be t, I have substituted this cos x. Differentiating both sides, minus sin x is equal to dt by dx, and we cross multiply this dx here. So I got sin x dx can be replaced by minus dt. So this sin x into dx, it can be replaced by minus dt. So your integral becomes minus, I can take outside, and dt. Now you are left with sine of cos x. So sine of and cos x you have substituted to be t. So basically we have made this substitution here in this integral. So I got minus sine t dt, and now I have to integrate sine t. Negative sign is common. What is the integration of sine t? It's going to be minus cos t plus a constant of integration. Now minus minus becomes plus, and we replace t by cos x. So we have the answer cos of cos x plus a constant of integration. Now next question number 5. The integral I, it is given to be sine of ax plus b into cos of ax plus b dx. So here the problem is that both the functions are composite functions. The two functions are multiplied and they are composite functions. So I will substitute this ax plus b to be t. Differentiating both sides with respect to x. Derivative of ax is a, derivative of b is 0, and derivative of t is going to be dt upon dx, and dx we cross multiply here. So we got a dx to be dt, or I can say that dx can be written as dt upon a. So let us try to make this substitution in I. Sin ax plus b becomes sin t, cos ax plus b becomes cos t, and dx becomes dt upon a. Now you know students, a is a constant, so 1 upon a can be taken outside the integral sign, and then we have sin t cos t dt. Now we multiply and divide this sin t cos t by 2. So therefore this denominator, the 2 in the denominator can also be taken outside, so this becomes 1 upon 2a, and 2 sin t cos t can be written as sin 2t dt. Now 1 upon 2a remains out, and integral of sin 2t will be minus cos 2t divided by the derivative of this 2t, which is 2. So whenever you have a composite function to integrate, and but the thing is that it has to be only a linear thing, then you divide the answer by its derivative. So now again you can write 1 upon 4a, negative also you can write outside common, and cos 2t plus a constant of integration. T can be replaced later now by ax plus b. So minus 1 upon 4a cos 2 times of ax plus b plus a constant of integration. This is your answer. So now let us move to the question number 9. So here, first of all, I will take 2 common from 4x plus 2. So this becomes 2x plus 1 square root of x square plus x plus 1. Now students, can you tell me, is there any term which is derivative of other term? So we can see that derivative of x square plus x plus 1 is 2x plus 1. So therefore you will put this term whose derivative is also present in the integral as t. You will substitute only that term whose derivative is also present. Otherwise you cannot use this method. And therefore now I can differentiate both sides with respect to x. 2x plus 1 is equal to dt by dx, and hence I get 2x plus 1 dx is equal to dt. So now students, in this let us assume this integral to be I. In this I, this 2 can be taken outside the integral, constants can be taken common, and 2x plus 1 dx can be written as dt, and this root x square plus x plus 1 can be written as root t. So now I can rewrite this integral as 2 into integral of t raised to the power 1 by 2 dt. So which is equal to 2, and now I have to integrate t raised to the power 1 by 2, which is t raised to the power 3 by 2 upon 3 by 2 plus a constant of integration, which becomes 4 upon 3 t raised to the power 3 by 2. Now after this we have already integrated, and in the final answer we substitute back t to be x square plus x plus 1. So we get 4 by 3 x square plus x plus 1 raised to the power 3 by 2 plus a constant of integration, and this is your final answer. Now let us move back to question number 10. Let us assume it to be I. So before we make any substitution, we simplify it, and from the denominator I can take root x to be common. So inside I am left with root x minus 1. Now I can substitute root x minus 1 to be t, differentiating both sides with respect to x. Now what is the derivative of root x? Root x is actually x raised to the power 1 by 2. So we rewrite it, and now we find its derivative. So its derivative is going to be 1 by 2 x raised to the power minus 1 by 2 is equal to dt by dx. We rewrite it. So we get 1 upon 2 root x dx is equal to dt. Now students, you must be remembering this, that derivative of root x is 1 upon 2 root x. If you don't remember it, I have shown you here how. Now you should remember it. So now I can also write that dx upon root x can be written as 2 dt. So that means here I have to make the substitution dx upon root x. This dx upon root x, this becomes 2 dt, and root x minus 1 is t. So upon t. So now I can take this 2 outside the integral sign. So I have dt upon t, which is equal to, its integral of 1 by t is going to be log mod t. So now after this I will substitute back t to be root x minus 1 plus a constant of integration, and this is your answer. So let us first make a slight change into this. We simplify this to a little bit and then we start proceeding. X raised to the power 5 can be written as x cube into x square. After that, we shall substitute x cube minus 1 to be t. Differentiating with respect to x both sides, 3x square dx is equal to dt, and x square dx becomes dt by 3. So we are going to make this substitution. You can see the two expressions that I have put in box. Now I will substitute them in this expression. X cube minus 1 is t. So this first term becomes t raised to the power 1 by 3. Now since students you have written x cube minus 1 to be t. So x cube will be t plus 1. So that means this x cube can be replaced by t plus 1 and x square dx can be replaced by dt upon 3. So your integral becomes this 1 by 3 common, and now you multiply these two expressions, t raised to the power 1 plus 1 by 3, you have just multiplied, plus t raised to the power 1 by 3 dt. So first we shall simplify this, t raised to the power 4 by 3 plus t raised to the power 1 by 3 dt. Now you know children that the sign of integration can be distributed over addition and subtraction only, and therefore if 2 or 3 terms are added or subtracted, I can do their term wise integration. So now I will integrate both these terms, and which formula I am going to use? I am going to use this formula. Integration of xn is going to be x raised to the power n plus 1 upon n plus 1 plus c. So therefore 1 by 3 and t raised to the power 4 by 3. Its integration is going to be t raised to the power 4 by 3 plus 1 upon 4 by 3 plus 1 plus t raised to the power 1 by 3. Its integration is going to be t raised to the power 1 by 3 plus 1 upon 1 by 3 plus 1 plus the constant of integration. Now students, you have integrated. Let us simplify it further. So t raised to the power 7 by 3 upon 7 by 3, t raised to the power 4 by 3 upon 4 by 3 plus a constant of integration. So if you take this 3 common from the numerator, it will cancel down with this 3. So you are left with this. Now after that, at the final step, we shall substitute back t. T was x cube minus 1. So I write the final answer, that is x cube minus 1 raised to the power 7 by 3 upon 7 plus x cube minus 1 raised to the power 4 by 3 upon 4 plus a constant of integration. So this is your answer. Question number 14. Integral I is dx upon x log x raised to the power m. X is greater than 0 because it is in denominator and m is not equal to 1. That means because so they have given you that the power of m is not equal to 1. So what substitution you are going to make? You are going to put this log x to be t, differentiating both sides. So derivative of log x is 1 by x and derivative of t is dt by dx, cross multiplying, dx upon x is equal to dt. So let us make this substitution here. Right now I have explained you dx upon x can be replaced by dt. Log x, here you can see log x can be replaced by t raised to the power m. So now I can write it as t raised to the power minus m into dt. So now what is the integration of this term? T raised to the power minus m plus 1 upon minus m plus 1 plus a constant of integration. And you can substitute back later on t by log x. So you can write it as log x raised to the power 1 minus m upon 1 minus m plus a constant of integration, and this is your answer. Now students, question number 16 says I is equal to e raised to the power 2x plus 3 dx. Now let us recall the formulas done earlier. Integral of ex is ex only, and if suppose you are given e raised to the power not x but some function, so it's a composite function, so in such case this integral is going to be e raised to the power fx. Now the condition is this fx has to be a linear function. In case if this is a linear function, it is going to be e raised to the power fx upon f dash x. Fx is linear expression. That means here you can directly do it without substitution also by this method that I have explained you, that its integration is going to be e raised to the power 2x plus 3 upon derivative of 2x plus 3, which is 2, plus a constant of integration. Otherwise, if you want to use the substitution, you can use that. You can put 2x plus 3, this is the alternative method, to be t, differentiating both sides. 2 dx is equal to dt. So dx can be written as dt by 2. Let us make this substitution in the integral I. E raised to the power t dt upon 2. So now you integrate 1 upon 2. Integral of et is et. So now in the end you replace t by 2x plus 3, and so we can get the same answer as we have got here in one single step. Now here students, you can see that again you have a composite function. So denominator may you have e raised to the power x square, and if I put this x square to be t, differentiating both sides 2x dx to be dt. So this I becomes, also I can write that x dx is dt by 2. So this x dx is dt by 2, and e raised to the power x square means e raised to the power t. So I can write 1 by 2 dt upon et. So 1 by 2 I can write e raised to the power minus t dt. So its integration is going to be e raised to the power minus t divided by derivative of minus t, which is minus 1. So minus 1 by 2 e raised to the power minus t, that is minus 1 upon 2 e raised to the power t plus c. Now you replace t by x square. Now students, I end up this class with this question, and we shall be completing this exercise in my next video. Till then, keep studying, keep revising, and don't forget to like, share and subscribe this video.